Okay, so here's an example where we can use what we learned about Jacobians to change coordinates and evaluate an integral. Now, what we want to do is evaluate this integral right here over this region. The region R is the region, it's this parallelogram. Setting this up in terms of x and y, go ahead and try it. You'll see if you just try to use the coordinates x and y, you can actually do it, but it's rather complicated. I don't know if complicated is a word, but tedious maybe. You've got to break this region up into several pieces if you want to do it dx dy. And so it's somewhat tedious. Go ahead and try it and see what happens. So it's going to be easier if we change coordinates. What we want to do is we want to look at these line segments that define the borders of our region. And just using, I mean, you know the points. We got these points, so you can find the equations of these lines. So I'm going to save you the time here and say that we figured these out. So go ahead. It's a good exercise to do that. Find the equations of these lines. All right, so I'm just going to write them down for you. All right, suppose we went through the work. This is x minus y equals 1. The equation of this line is x minus 3y equals negative 9. The equation of this line over here is x minus 3y equals negative 5. And the equation of this line over here, that's x minus y equals negative 1. Okay? So by getting an idea of what these border lines are, we can get an idea of what change of coordinates we should make. One thing I'm noticing is that this line and this line have the same expression on the left-hand side. It's x minus y. X minus y went from negative 1 to 1. And these lines have the same expression on the left-hand side. It's x minus 3y. So x minus 3y goes from negative 9 to negative 5. So that suggests a change of coordinates. All right? That suggests that we should think of these coordinates. U equals x minus y, and v equals x minus 3y. Because you see, then u goes from negative 1 to 1, and v goes from negative 9 to negative 5. This is just defining a rectangle in these coordinates. So let's draw this picture in the UV coordinate system. Oops, I should have, oh man, I shouldn't have drawn it like that. I should have included more negative values, all right? So I'll have to fudge things a little bit. U, we said, goes from negative 1 to 1, right? And V goes from, see, I should have gone down to the negatives, negative 9 to negative 5, all right? So what we're getting in the UV coordinate system is we're getting a rectangle down here. So this region becomes this region in the UV coordinates. Quite a simple region to deal with now. So that'll make that integral much easier to do, much less tedious. Okay, so what do we have to do? Well, we have to compute the Jacobian. If we're going to convert from dy dx to du dv, we need to multiply by the Jacobian. The Jacobian is determined by, let's write it down. The Jacobian is one way to think of it is the determinant of x u y u x v y v. Oh, off the screen, sorry. It's the absolute value of this determinant. So it's the absolute value of x u y v minus x v y u. Okay, that's what we have to do. So what we're doing here is we're thinking of x and y as functions of u and v. Well, we have them the other way around up here. We have u and v as functions of x and y. So can we invert this relationship? You absolutely can. This is a system of equations. You can solve it for x and y in terms of u and v. Just to kind of get an idea of how to get started here, if you just subtract these two equations, if I take u minus v, all right. Well, the right-hand side is x minus x. That's the x is gone. Negative y minus negative 3y is 2y, right? And so that tells us that y is equal to u minus v over 2. And if I want to solve for x, I might try to do the same thing, but to try to get the y's to cancel off. So why don't I multiply the top equation by negative 3? All right, so bring that over here. Just multiply everything by negative 3. And now add this equation to that one, right? So now the y's are going to cancel, right? So I have v minus 3u. When I add these, and then when I add the right-hand sides, I get negative 2x. And the y's cancel, right? So I get this equation. And then if I divide both sides by negative 2, I get x equals 3u minus v over 2. Okay, so I've solved for x and y. So now I can compute the xu and the yv. So let's go ahead and do that. So I can just do that over here. I need to compute xu, xv, yu, and yv. I've got to compute all of these. xu, that's 3/2. Well, xv, that's negative 1/2. Yu, that's 1/2. Yv, negative 1/2. All right. So now I can do this up here. Xu yv, well, that's 3/2 times negative 1/2. That's negative 3/4. Right. And then an xv yu, that's negative 1/2 times 1/2. That's negative 1/4. Negative 3/4 plus 1/4 is negative 2/4. When I take the absolute value, I get 1/2. So the Jacobian here is just 1/2. Okay, so if I'm converting from dy dx to du dv, I need to multiply by 1/2. All right, that's what we're saying here. Dy dx is equal to 1/2 du dv. Or you could say dv du, it doesn't matter. Whichever order of integration makes sense here in this picture, although either one is the same. It is just as easy because it's a rectangle, right? All right, so let's finish rewriting our integral. All right, so our integral, let's see what happens here. X minus y, what is that in terms of u and v? Well, that's exactly u, right? There you are. It's just u. And then we said the dy dx becomes 1/2 du dv. Okay? Now, what do the bounds become? Well, here, I think looking at these equations, you can figure it out, right? Because you know what the bounds were in terms of x and y. You can plug them into these equations, and you can figure them out. However, I think it's easier just to look at the picture. If you got the picture, just use that. I mean, look, u goes from negative 1 to 1, right? So negative 1 to 1. And then v goes from negative 9 to negative 5. And so now we can do this integral. Integrating over this nice, easy rectangle. So the antiderivative 1/2 u, well, that's 1/4 u squared, evaluated from negative 1 to 1. And then we're still going to integrate this. We haven't integrated from the dv part, right? You plug in 1, plug in negative 1, subtract, you get 0. So the answer here is 0.